All right, I'd like to show one more thing that this was called a simple harmonic motion. Let me remind you of that. Here that simple harmonic motion. Of course, there's out there a complicated harmonic motion, I think. So in general, the motion of some periodic motions is more complicated than just a sine function. So I'm going to show you what happened if we actually combine this sine and cosine with a different angular speed involved in there. So here I'm looking at some combinations of two different types: sine of k1t, that is coming from some proportionality of the Hooke's law or the principle of simple harmonic motion, together combine it with cosine of k2t, which is coming from a different system. Suppose this is actually the air molecule, and whatever its forces acting on this air molecule right here is causing this type of motion or force, and this one is also acting on there and creating a different type of motion. So one particle and two different sources of power, two different natures of forces is kind of acting on the same particle, and figure out maybe with it we can just add this thing together. So it turns out, for example, the motion, the position after t seconds is governed by this type of formula, sine of k1t and cosine of k2t. And you can also hit it with different strength in here. So if you multiply the large number, you can imagine that the sine function going up and down with a lot more oscillation, and you can play with the different numbers. You can kind of think about this type of motion, and there is some physical principle you can write down, and through a differential equation you arrive this type of a thing. So it's the motion of the particle that is kind of bounded up and down and still moving with some periodic properties, something like this. Let's write it down. Periodic properties can be analyzed in this fashion, like this. So it's very, very important result in mathematics and for all science, that like air molecules and all the waves that we observe in the nature is interpreted using the sine and cosine, not because they look like it, but because of the principle we understand about this motion is exactly matching the function that we invented from the triangle. So here's an example. So this is going to be the example I'm going to show you using Mathematica. Here I didn't use cosine, here I actually use a sine. If you think about it, the relationship between sine and cosine is a shift from left to right. What it corresponds to the motion is just a different initial positions. From that interpretation, I think you can understand the frequency, the amplitude doesn't change. It's just a different initial position, and if the same forces are acting onto the system, and you can see, you expect the same type of properties and behavior. So there's not much difference about sine and cosine. Again, it's slightly different position to start with. So this is what I sketched, and here this is what I'm going to show you. So here's this crazy picture. You can see there's a thin blue and the black, and those are the two terms in that sum. After you add it, you can see that the motion gets more interesting. If you look at the individual ones, for example, the blue, that is kind of simple harmonic motion going up and down, governed by the one principle or one source of the power, force. And if you look at the black one, it's going up and down with a different frequency and different amplitude. It's a simple harmonic motion. So if these two forces acting together, it creates this interesting motion on here. You see the up to here looks like a simple harmonic motion, but here all of a sudden it behaves a little bit different, and so on. So the creation of all the different interesting sounds is coming from the understanding this type of a decomposition. So if you want to know how this sound to be decomposed, and you want to know what are those, the black and blue that is involved as components of simple harmonic motions. So this decomposition is an important part of our analyzing the motions and the sound and waves. So let me put this into an animation. So here's the animation. This is the red dot here is actual motion on this vertical. Just think about there is a mass attached to spring. So spring and then gravity happen to not be the only source of this force. We're doing something in there. Maybe it has its own an expulsion in there. Some third source of force is acting on that little dot in there and creating the following crazy motion. So that graph you just looked at together is represented here and in this, or expanded over the time period, but actual motion in here is represented in this vertical line. All right, this is our first slide, and let me summarize it here. The simple harmonic motion governed by this principle and using mathematics is related to the sine and cosine functions, and all the other complicated motion that's periodic or bounded up above and below can be analyzed in terms of the sine and cosine. Thank you.